Okay. Well, welcome to Central Iowa, our user group online workshop. Today we have Xuqing to give us an introduction to causal mediation analysis. Before we start, still as a reminder, you can get to scientistcafe.com and download the slides here for today's talk. And also, if you are interested in our future talk, you can go to our meetup site, register there, or you can follow me on Twitter. If you have any question during this talk, you can leave your question under the event page, or if you register from meetup site, you can leave your message under the meetup site. I will check occasionally. All right, I will give it to Xu now.
Okay. Hello, everyone. Thank you very much to join us today, and thank Lin for inviting me here. Today, I would like to give you an introduction to causal mediation analysis.
Can you share your screen?
I'm going to share my screen.
Yep.
Okay. Can you see my screen?
Yes.
Okay, so let's start now. So as you may have already noticed, I would like to emphasize causal here. All of our discussions today will be focused on causality. So causality. When learning many statistical methods such as linear regression and ANOVA, we're often told that these tools can only help us investigate associations. However, in the real world, what we're really interested in is causality. For example, sociologists want to know whether divorce affects children's education, and medical scientists are interested in whether a new drug effective against a disease. And economists asks, does a job training program improve participants' earnings? And also businessmen cares about whether a sales reward program can really boost a company's profits. So here we call divorce, drug training program, and sales reward program in these examples as treatment or intervention. And once a significant or an insignificant causal effect of the treatment is detected, people want to further investigate what's going on inside the pathway from the intervention or treatment to the outcome. And some people call it the black box of causality. How can we learn about it? How can we know what is happening inside the pathway? In fact, mediation analysis helps us uncover the black box. As Barron and Kenny wrote in their most famous paper in the mediation analysis literature, mediation represents the mechanism through which the focal independent variable, which is namely our treatment, is able to influence the dependent variable of interest, namely outcome. By the way, I found on Google Scholar today that this paper has been cited as many as over 60,000 times. From this number, we can also tell how much mediation is of interest among researchers. In mediation analysis, the total treatment is decomposed into an indirect effect transmitted through the hypothesized mediator and a direct effect representing the contribution of other unspecified pathways, like this. So this pathway, we call it indirect way, and this one is direct. So the total treatment effect can be decomposed into an indirect effect transmitted through the mediator, and all of the effects transmitted through the other unspecified pathways are incorporated into this direct way. To help you have a more intuitive understanding about this concept, let's take a look at a real example. So family socioeconomic status, SES here stands for socioeconomic status. It is a powerful predictor of many aspects of child development, including child vocabulary. So in this example, let's focus on the impact of SES on child vocabulary. It is well established that the children from lower SES build their vocabularies at slower rates than children from higher SES. In this example, we aim to identify the pathways by which SES exerts its well-established influence on child vocabulary capability. Mother's talk to children differs as a function of SES. And also, the properties of mother's talk to children account for individual differences in the rate of children's vocabulary development. Therefore, our hypothesis here is that the maternal speech mediates the relation between SES and child vocabulary development. Therefore, what we're trying to do now is to decompose the total impact of SES on child vocabulary into an indirect effect, which is the improvement in child vocabulary attributable to the SES-induced difference in maternal speech, and a direct effect, which is the impact of SES on child vocabulary without changing maternal speech. So this is a general picture of the hypothesized mediation mechanism. Then you may want to ask, how are we going to estimate the direct and indirect effects? First of all, I would like to show you a conventional estimation method. So by regressing the outcome on the treatment, we're able to estimate the total treatment effect, C. Here we denote the total treatment effect as C. And then we fit a mediator model by regressing the mediator on the treatment. And so by regressing mediator on the treatment, we're able to estimate the effect of T on M, so we can estimate this pathway, A. And then we regress Y on T and M, we're able to estimate direct effect and the mediator effect on Y controlling for T. So all of these pathway coefficients can be estimated by fitting the mediator model and outcome models. Now we're able to estimate the direct effect C prime and the indirect effect. The indirect effect is the product of A and B. And also it can be estimated by subtracting C prime from C, because as you may notice, the total treatment effect is the sum of the direct and indirect effect, right? So the indirect effect is equal to the total treatment effect minus the direct effect. And you may find more details in these papers, and these are very classical articles in literature. The key challenge, the major challenge is the significance test for the indirect effect. As you may find, the indirect effect is a product of two coefficients, A and B. So Sobel derived asymptotic sampling variance of the indirect effect using delta method in 1982. However, the problem is that the test statistic is approximately normally distributed only in large samples. When sample size is small, the product of coefficients distribution is not normal. Therefore, people develop non-parametric methods, such as bootstrapping and Monte Carlo method, to test the significance of the indirect effect. So this is the conventional estimation method. And then I'm going to briefly talk about the limitations of this method. The path coefficients are of causal meaning only when the functional form of each of the models is correctly specified, and also only when there's no confounding of the Ty relation. Some of you may not be familiar with the concept of confounding. So confounder is just a covariate associated with both T and Y. For example, children from lower SES may differ in the values of their background characteristics from those from higher SES. At the same time, these characteristics may be associated with their vocabulary capability. If there is a confounding of the Ty, namely the treatment outcome relationships, any variable that causes both T and Y must be included in the model. Well, as I showed before, in that model, people haven't taken into account those confounding factors. And also, the path coefficients represent the causal effects of interest only when there's no confounding of the Tm, meaning the treatment mediator relationships, and also there's no confounding of the My relationships. And those confounders might occur before the treatment or after the treatment. And also, this is also a very important thing, is that there's no interaction existing between the T and M when they affect Y. However, this typically, so try to imagine that in reality, it is actually very common that there is interaction between T and M when they affect Y. So, for example, higher SES mothers show more of the characteristics of maternal speech that are positively associated with language development than lower SES mothers. So, meaning when fitting a regression, if you think that higher SES mothers might show more of the characteristics of maternal speech that are positively associated with language development than lower SES mothers, then you may want to include the TM interaction term in the regression instead of simply ignoring that. So if you really ignore that, this typically overlooks the fact that a treatment may generate an impact on the outcomes through not only changing the mediator value, but also changing the mediator outcome relationship. And if you want to know more about it, you could read Jewett and Kinney in 1981. So previously, I just showed the conventional methods, estimation methods, and the limitations. Now, I would like to show you the analytic methods that can really help us investigate the causal mediation mechanism. The causal mediation mechanism. Let's emphasize that again. Before that, let's take a brief look at potential outcomes framework. Many causal inference approaches are developed within this potential outcomes framework. I would like to recommend this book written by Imbens and Rubin in 2015 to all of you. This book uses the potential outcomes approach to connect theory of causal inference to the real-world analysis in medicine, in public policy, and in many other fields that may of interest to you. I read this in their book, and I found it a very vivid example to understand potential outcomes, so I would like to share it with you today. Many of you might have watched the movie It's a Wonderful Life. In this movie, the leading role, the one on the left, George, lives in a village named Bedford Falls, as you can see here. And after some experiences, he becomes very depressed and states that the world would have been a better place had he never been born. And suddenly, an angel appears and shows him what the world would have been like had he not been born. In the counterfactual world, had he not been born, Bedford Falls, that I mentioned before, that he lived in, becomes Pottersville. In the world had George not been born. For example, in that world, his younger brother, who was a World War II hero in actual life, drowns in a skating accident at age 8 in a counterfactual world because George was not there to save him. And then, as you may see from this example, the actual life in Bedford Falls is the observed outcome, while the life in Pottersville, had George not been born, is the counterfactual outcome. The causal effect of George's life is the comparison of the entire stream of events in the actual world, with George in it, with the entire extreme of events in the counterfactual world without George in it. In reality, we would never have the chance to see both worlds, but in the movie, George gets to observe both. And then, by making the comparison, George finally realizes how substantial the causal effect of his life is, and he becomes very happy and lives happily together with his family. So I hope this example can help you have a better understanding about this potential outcomes causal framework. So the key message that we learn from this story is that the definition of a causal effect is a comparison of potential outcomes for the same unit. Now let's take a look at the definition of causal effects in a more formal way. So we define potential outcome as a function of treatment. Here we assume the treatment has two levels, 0 and 1. So we define individual i's potential outcome under t equals 1 as yi1, and its potential outcome under t equals 0 for the same individual is yi0. And by taking the difference between the two potential outcomes, we define the treatment effect for each individual. This is like for George, and one potential outcome is he lived the actual world that he lived in, and the other potential outcome is the counterfactual world had he not been born. And now we compare two potential outcomes for the same individual, George. Then, by taking the average over all of the individuals, we obtain the population average treatment effect. Okay. Now, I would like to use the impact of SES on child vocabulary as an example. Let's consider the case of a single unit. For individual 1, there are two treatment levels, low SES and high SES. If individual I is from high SES family, then his potential vocabulary score is denoted as Y1, and the value is 16. If he's from low SES family, his potential score is denoted as Y0, and it would be 14. In this way, we are able to define the causal effect for individual I by comparing the two potential outcomes. And similarly, we're able to define the potential outcomes for all of the other 4 individuals in our population here. And that by taking the average over all of the individuals in the population, we get the true averages. So as you can see, the true population average treatment effect is 7. And this is just based on the potential outcomes framework, assuming that we know the potential outcomes under both treatment conditions. And this definition is based on the SUTVA assumption. The full name is Stable Unit Treatment Value Assumption. And it is assumed that there's no interference among individuals. In the SES example, it means that other children's SES cannot have an effect on the child's vocabulary. This means that this might be violated if the children live close to each other. This is often called spillover effect, and methods have been developed to solve the problem when this assumption is violated. And besides no interference, it is also assumed that there's only one version of each treatment level. Say, for each unit, there are no different forms or versions of each treatment level, which lead to different potential outcomes. So we define the causal effects under SUTVA. Our next task is to identify the causal effect, because As you remember, in the real world, George would never have the chance to observe the world had he not been born. Similarly, in reality, we can only get this table instead. In this table, because individual I is assigned to the treatment group, to the t equals 1 group, only y1 is observable for this individual, while y0 is missing. So that's why people also call causal inference missing data problem. So for individual I, for individual 5, because he is assigned to the control group, we're only to observe y0 while y1 is missing. So in this way, we're not able to get the causal effect for each individual. Each individual's causal effect is missing. And how are we going to identify the total treatment effect that we defined before? What we can only do is to use the observed data. What we can get from the observed data is that the expected outcome in the t equals 1 group is equal to 15. And the expected outcome it should be t equals 0. In the t equals 0 group is 8. And by taking the difference between the two, we can only get the group mean difference. It is 7. And as you may remember, the true average that I show in the first table is that the population of y1 is equal to 15 and the expectation of y0 is equal to 8. So as you may find, if the expectation of the potential outcome under t equals 1 is equal to the expected outcome in the t equals 1 group, if these two are equal and these two are equal, finally we're still able to identify the causal effect that we define in the potential outcomes framework, right? And so you may ask, how can we realize this? In fact, this can be realized in a randomized experiment. In a randomized experiment, T treatment is independent of potential outcome. YT is independent of T. And we also call that T is ignorable. Under the ignorability assumption, the expectation of YT is equal to the expectation of YT under T equals T. And this is in fact just equal to the expectation of Y under T equals T. Therefore, delta is just equal to the group mean difference. In this way, we get the identification result. We can also understand it in this way. Since the individuals in the T equals 0 group and the T equals 1 group have the same characteristics due to randomization, the T equals 0 group can be used to predict the counterfactual information for the individuals in the T equals 1 group. So that is the basic idea of identification. But now we're only focused on randomized experiment. But how do we identify the causal effects in observational studies? In observational studies, we're able to identify the causal effect under a strong ignorability assumption. The assumption that I showed in the previous slide is called ignorability assumption, saying T is independent of YT. Now, the strong ignorability assumption brings in the covariates. Given the covariates, T is equal to is independent of YT, we are still able to identify the causal effects. And what does X stand for here? Here, the covariate vector X, which is measured prior to the treatment assignment, is a vector of potential confounders that are correlated with both the outcome and the treatment. This assumption states that within levels of the observed confounders, the individuals are as if randomly assigned to each treatment condition. If we select enough confounders so that the assumption holds, then the population average treatment effect can be identified by taking the expectation over the conditional expectations given X. Is it clear here? So now we are able to define the causal effect and then identify the causal effect by relating the counterfactual world to the observed world, and either in the experimental design or in the observational studies. Now our task turns to be the estimation of the causal effects. So the estimation of causal effects are mainly realized based on propensity score-based methods. You may find the details in Rosenbaum and Rubin in 1983, and there are a bunch of other papers on these methods, including matching, subclassification, covariance adjustment, and inverse weighting. This may be unfamiliar to many of you, but since this is not our focus today, I will briefly mention it. The basic idea is to...
Could you share your screen again? People said that when screen sharing stops them.
Sorry, what did you say?
The screen sharing. Can you share your screen again?
Okay.
Some problem.
You mean I stop sharing and share it again?
Yeah, share again. See if it works.
Okay. Does it work?
Yep, now it works.
Okay.
Thank you.
Sorry about So, did people miss some slides?
I don't know when it's 6:25. I received message 6:25 about 2 minutes ago.
2 minutes ago.
Yeah.
So, maybe I'll just quickly go through these 2 slides.
Yeah.
Yeah, so this slide is about identification of causal effects in randomized design. As I said, assuming T is independent of the potential outcome, we're able to identify the causal effect. And then we come to the observational world. In observational studies, we're able to identify the causal effect under the strong ignorability assumption. The only difference is controlling for the confounding factors. And the confounding factors are defined as the covariates associated with both the treatment and the outcome. And this is the identification results. Is it good?
Oh, it's good now.
Okay. Thanks. Then let's come to the estimation of causal effects. And the methods include these 4 methods and some other methods. I just show the most popular methods, including matching, subclassification, covariance adjustment, and inverse weighting. And the basic idea of these methods is just to predict the counterfactual information that cannot be observed with the observed data. And a key question that people always ask is how can you guarantee that the identification assumptions are satisfied? That is a tough question. So in causal inference, it is crucial to check whether the identification assumption is satisfied. Sensitivity analysis is essential. The goal is just to quantify the degree to which the key identification assumption must be violated for a researcher's original conclusion to be reversed. So the basic idea is that if I assume there's one important confounder omitted, then I'll study how big the bias will be caused by the omission of that important confounder. If even if I omit the confounder, my original conclusion is not reversed, then that is fine. If so I compare 2 situations. One is that I consider this confounder. One is that I omit this confounder. If the significance, so if for when I omit this confounder, the causal effect of interest is positive. Well, if I include this confounder, the causal effect effect is like, let's say, negative or insignificant. The conclusions are reversed, then we say the results. Then we say it is sensitive. So this is the basic idea of sensitivity analysis, and there are a lot of sensitivity analysis approaches developed in literature even today. So if you're interested in it, you can search for it online. But the classical article is from Rosenbaum, 1986.
And how do you know? How do you know in real situation the confounder exists or not?
Sorry, can you say that again? It's not very...
How do you know in real situation the confounder actually exists or not? Because
Okay.
that's going to be the true issue. How can you know which one is the true issue?
Yeah, that is a good question. One common approach is that people select one most important confounder from the observed confounders that you have.
Okay.
So you have a bunch of confounders at hand, and then you select the most, like, let's say, strongest confounder among those observed confounders. And let's assume if this strongest confounder is omitted, let's drop it and see your conclusion.
How do you know the confounder is strong or not?
So usually there's like people derive the bias equations, like formulas for bias. Then I actually calculate the bias when each one is omitted. The strongest one is the one can cause biggest bias if it is omitted.
Okay.
Or let's say if it is, let's just look at the correlation between this variable and the outcome and the treatment. If the correlation is strongest, then we say it is the strongest confounder. So overall, it is the strongest confounder that can cause the biggest bias if it is omitted. If the confounder, the observed confounder that can cause the biggest bias, the omission of that confounder, if the omission of that confounder cannot cause your conclusion to be reversed, then let's say your conclusion is not sensitive. Is it clear?
Yeah, thank you.
Mm-hmm. And then here I list a software website that you may find helpful, because this is from Professor Elizabeth Stewart's webpage. And this webpage, it includes a lot of software, including R packages. I think you may find it helpful if you want to do causal inference. And you may ask, your title is Causal Mediation Analysis. Why do you spend so much time talking about causal inference instead? Actually, in order to have a better understanding about causal mediation analysis, I think it is important to have a basic idea about causal inference. First, I hope now you have already got a general idea about causal inference. If you have any questions, you can interrupt me now, and if not, I would just go to causal mediation analysis.
Oh, one more question.
Mm-hmm.
For the treatment, does it have to be categorical?
No, actually, recently a lot of people are studying continuous treatment in literature.
Right. Thank
you. Mm-hmm. Thanks. Given that we have got a general idea about the potential outcomes causal framework and basic causal inference, we're able to have a better understanding about causal mediation analysis under the potential outcomes framework now. So here are the two books that I would like to recommend if you want to learn more about causal mediation analysis. The first book is Causality in the Social World, Moderation, Mediation, and Spillover. And social scientists may find it easier to understand. And the second book is written by a a leading expert in mediation from Harvard. So when doing causal mediation analysis, your first research question is always about the total treatment effect. Recall that our initial question is the impact of SES on child vocabulary. How much is the average SES impact on child vocabulary? We then try to identify the pathways by which SES exerts its well-established influence on child vocabulary capability. That's our next task. And so we come to the research question 2. As I have already mentioned, mothers' talk to children differs as a function of SES. And properties of mothers' talk to children account for individual differences in child vocabulary development. Therefore, the hypothesis is that the maternal speech mediates the relation between SES and child vocabulary development. So our second research question is about the indirect effect transmitted through maternal speech, namely, how would the SES-induced change in maternal speech exert an impact on child vocabulary? Now, we try to define the indirect effect under the potential outcomes framework. Mediator is in essence an intermediate outcome. So, as you may be able to imagine, potential mediator can be defined as a function of t, like it defined y1 before. Here we define the potential mediator under t equals 1 being m1. So if SES is high, if individual I is from high SES family, then his potential mediator is defined as m1. And if he's from low SES family, his potential mediator is defined as M0. Now, we try to define the potential outcome. Yeah, this may take you some time to understand it. So as we have mentioned before in the diagram, the outcome is affected by both the treatment and the mediator. We therefore define the potential outcome as a function of the treatment and the potential mediator. So try to imagine what is the potential outcome, how to define the potential outcome under the treatment condition. So when t equals 1, the potential outcome is defined as y1 m1. It is defined as a function of both the treatment and the potential mediator. And it is the vocabulary score for child I if he is from high SES family. And this actually can be simplified as y1. And why? So under the control condition, the vocabulary score for child I if he is from low SES family, it can be defined as y0 m0. And similarly, it can be simplified as y0. And the tough part is here. For individual I if he is from high SES family, but counterfactually he received the amount of maternal speech as he would receive if he's from low SES family, we define it as y1 m0. Let's repeat it again. So, because this is a tough part, I'll repeat it again, try to understand it. So y1 is 0, y1 m0 is the vocabulary score, namely the outcome. Here y is the vocabulary score, and m is SES, maternal speech. So y1 m0 is the vocabulary score for child I if he's from high SES family, but counterfactually, he received the amount of maternal speech as he would receive if he's from low SES family. Now, we are able to define the indirect effect. Because, as I mentioned before, when talking about indirect effect, we want to see how much the SES-induced change will affect the outcome. So what we're going to do is to control T at 1 and change potential mediator from M0 to M1 and see the change in the potential outcome. So this is actually the change in the potential outcome caused by the change in the program-induced. So this is actually the change in the potential outcome caused by the program-induced change in the mediator. And in literature, we call it natural indirect effect. And this is defined in Pro's paper in 2001 and is widely used in literature. Similar to what we mentioned before, this is defined under SUTVA assumption. Any questions about this?
Oh, one more.
Mm-hmm.
Here, you don't get the difference for the second one. Means when treatment is 0 and maternal speech is 1. So then you have the upper corner, upper right.
You mean this cell?
This cell, and you minus the bottom cell, you can get another maternal effect.
Yeah, that is a very good question. Actually, so in literature, people only focus on this part, while in another paper written by Robinson Greenland in 1992, they actually defined this part. So this is defined as pure indirect effect, and this is defined as total indirect effect in their paper. And here I just want to simplify the whole discussion, so I dropped this part. And also in literature, people mainly focused on this part. The main reason is that they want to see the change in the potential outcome caused by the program-induced change in the mediator. So they really want everybody to receive the treatment. So for the impact of the pure treatment on the outcome, and they just want to see the change in the mediator. But you can also say I can see the difference between E0M1 and Y1M, the difference between Y0M1 and Y0M0.
Can you scream again? I think your scream is gone again.
Oh, sorry.
People, it's alright. I don't know why. Technique here is tough today.
Yeah.
Okay.
So my answer is that yes, you can definitely define the indirect effect by comparing these two potential outcomes. Here, just for simplification, I only show this part. If you read a paper written by EMI that I will show you later, in their paper, actually, they include both two. But in literature, especially when you do applications, maybe you just want to focus on one, then you can focus on one. And also, if you focus on two, you may find the difference between the two. Between the two is actually called natural treatment by mediator interaction in the paper written by Professor Guanglei Hong, who is my advisor. So she actually discussed the difference between these two indirect effects, and that is a more advanced topic. So yeah, just to simplify the problem, I just to show this part. But yeah, that's a very good question.
Thank you.
And then if no more questions, let's come to the direct effect. So this is direct effect. The question is like, how much is the average causal effect of SES on child vocabulary? without changing maternal speech. So you control for maternal speech and see the change in the outcome caused by the other pathways. Similarly, to define the direct effect, we want to see how much the change in the treatment will affect the outcome while the mediator is kept unchanged. Therefore, we control the potential mediator at M0 and change the treatment from 0 to 1 and see the change in the potential outcome. And this is often called natural direct effect in literature. Similarly, we can also define this part. And this part is defined as total direct effect in Robinson, Greenland, 1992. But here again, for simplification, I just show this one instead. And if you sum up this one and the one that I showed before, you can see that the sum of natural direct effect and the sum of natural direct effect and natural indirect effect is exactly equal to the total treatment effect. So this is how we decompose the total treatment effect. I have spent a lot of time in defining the causal effects because the causal mediation effects, because this is maybe very unfamiliar to most of you, and you may need to spend some time in understanding it. And actually, I'm going to show you alternative definitions. So this is alternative definitions. In Pearl 2001, instead of defining the natural direct and indirect effects, he also defined control direct effect. For comparison, I show you natural indirect effect here. And are you able to find the difference between the two?
Mm-hmm.
The major difference is that in control direct effect, the mediator is controlled. It is a value, the real value of the mediator that one received. While in natural indirect effect, the mediator part, it is a potential mediator. So in the natural indirect effect part, actually the mediator is caused by the treatment, while in this manipulation part, in the control direct effect, M is manipulated. That is the major difference between the two.
What do you mean by manipulated?
So you control the mediator to
you assign it, right?
Yeah, so like you can assign people to a treatment group or a control group. Similarly, you said that this person's mediator should be this value. I actually manipulate this person's mediator to be some value. While in the real world, the mediator value is actually naturally generated. It happened in a natural process instead of manipulating it, right? So the essential difference is that in the definition of the control direct effect, the mediator is manipulable, while in the definition of the natural direct and indirect effects, the change in the mediator is induced by the treatment. Since mediation is more often a natural process in the real world, researchers are more focused on the natural direct and indirect effects nowadays. So the natural indirect effect can better reflect the real world. So the mediator is caused by the treatment instead of I manipulate the mediator value. Is it clear?
Yeah, thank you.
Mm-hmm. Okay. So because nowadays a lot of methods are focused on natural indirect and direct effects, so the following discussions will be focused on this definition. And again, I will show you the identification of the causal effects, because as you may notice when I talk about the causal, no matter in causal inference or no matter in treatment effect or in the causal mediation analysis, I'm always talking about definition first, and then identify it. After that, I do the estimation, and this is the general, this is just the general logic in this world. By extending the identification assumptions that we mentioned for the total treatment effect previously, it is easy to understand the identification assumptions for natural direct and indirect effects. And as you may remember, so the key problem in that table, the key problem is the cell off diagonal, Y1M0. So we face an identification problem since we don't observe Y1M0. And so in this causal mediation world, we need more identification assumptions. We call it sequential ignorability. So in the first step, the treatment, similar to treatment effect that I mentioned before, the treatment is independent of potential, either potential intermediate outcomes or potential outcomes. We call mediator intermediate outcome here because it happens, it is an outcome happening in the intermediate process. So the T is independent of the potential mediator and potential outcome. This is similar to what we saw before. The second part, it is saying within levels of pretreatment confounders, the mediator is ignorable given the observed treatment. Okay.
Sorry. Here. What is X here?
Oh, sorry, can you say that again?
What is X here?
X is the confounder.
Confounder. Okay.
Yeah. Like we mentioned in causal inference part, the first part when I show you the potential outcome causal framework, in that framework I mentioned ignorability assumption in the randomized design, and in observational studies I mentioned the strong ignorability. Yeah, I think it may be better to go back and yeah. So this is the identification of causal effects that I mentioned previously in observational studies. So we bring in the confounders. Controlling for the confounders, we assume that the treatment is independent of the potential outcome so that we can see a randomized world after controlling for the confounding factors.
Okay.
And then we're able to identify the causal effects.
The confounding factor could be just like the kids, they live close by each other. Is that a confounding factor then?
That is actually about SUTVA. So yeah, SUTVA is for the definition of the causal effects. So if the kids live close to each other, then there is interference among kids. Yeah, but let's say confounding factors mean that there are some characteristics correlated with both SES and child vocabulary. For example, let's say parent education. So the parent education is correlated with children's SES status. The higher the parent education is, the higher the SES status for that child may be. And also it is correlated with child vocabulary ability. Education is higher, then it's quite possible that the child has a higher vocabulary capability. So parent education here is like a confounder. It is correlated with both SES status and the vocabulary capability. So
you mean confounder that's related to both, but it doesn't really cost anything.
Right. So if you find that the SES has a impact on, let's say, positive impact on child vocabulary, there is some confounding factors involved. Let's say parent education. You cannot purely say that. You cannot say that the SES status purely causes a higher child vocabulary. What we're going to do is just to compare the students with the same parent education level.
Oh.
Assuming that the students have the same parent education level, you compare whether those students with higher SES status have higher child vocabulary capability.
Okay, that's clear.
Mm-hmm. Yeah, thanks for asking, so that I guess maybe some other people also have the same questions. So those are the concepts of confounding factors, and this is very important because when I talk about identification assumptions, actually it is almost all about confounding. And then when you do sensitivity analysis, you are also focused on confounding factors. You want to see whether you have controlled for enough confounding factors or not. And when we come to the identification assumptions in the causal mediation world, yeah, you just add one more assumption. Potential mediator is independent of the potential outcome given the treatment. So this is actually very clear. So it's like a sequential process. First of all, T affects MT, and then MT affects YTM. So you really want to see whether M is also independent of Y, given the treatment levels.
There's question asking what does the symbol that looks like an upside down capital pi mean? That's condition. That's independent of.
Yeah, that is symbol usually used in the causal inference literature, denoting independence.
Yeah.
Mm-hmm. Yeah.
Yeah.
Mm-hmm. Then we come to the existing analytic methods. I didn't plan to spend too much time on introducing the details of the methods. I'll just give you a general sense and give you a couple of references so that if you're interested, you can go and read them. It'll take a couple of days to have a better understanding about these methods. But I still think the most important thing is to understand the whole picture, understand the whole counterfactual causal framework, which may be unfamiliar to you. So now, I will show you the methods. The first one I want to mention is instrumental variable method. For some of you who have taken econometrics, you may have learned this method, and yes, it can help you to do causal mediation analysis. But the problem is that there's a very, very strong assumption here, exclusion restriction, assuming that there's a constant zero direct effect. It's assuming that direct effect is equal to zero, then the total treatment effect is just equal to the indirect effect. That is really a very, very strong assumption, because in the real world, you can really tell that the direct effect is zero. Yeah. Another problem is that it assumes that there is no treatment by mediator interaction. As we mentioned before, this is often not the case in reality. Because as you may still remember, so maternal speech, the impact of maternal speech on child vocabulary may be bigger if one is from higher SES family. So there is an interaction involved, while in the instrumental variable method, people usually ignore that. And another method is called marginal structure model. And actually, marginal structure model is very similar. So the basic idea is very similar to propensity score weighting when people estimate the treatment effect, as I mentioned before. They also use a weighting called IBTW. So they actually estimate both the control direct effect and natural direct and indirect effects. You may read these two papers to have a better understanding about it. And also the downside is that it assumes no treatment by mediator interaction. Another method is called modified regression approach. As you may remember, at the very beginning, I talked about the limitations of path analysis. I say that people ignore possible confounding factors, and also they ignore the interaction terms. So here in the modified regression approach, they include all of those terms. They include the confounding factors, and also they include the treatment by mediated interaction, and also they derive a new parameter for the direct and indirect effects. The parameters are more complicated than A times B that we mentioned before. So these three methods, I really don't quite recommend them, although modified regression approach will be easy to implement using existing software. They actually wrote, so this paper, Valeria and Vanderwall in 2013, they actually developed SAS and SPSS programs to help you implement this method. So if you are not R user, if you are used to SAS or SPSS, then you can use this approach. I will mainly talk about resampling method and the rating method. Resampling method first. So, I think I'll, maybe talk about resampling method first. So it is developed by Imai et al. 2010 two papers. So these two papers, I believe many of you are R users, and you may really like this method because they developed our package called mediation. And I think, I will just briefly show you the basic idea of this method. But generally speaking, the basic idea is just to estimate the tough one, EY1M0 that I mentioned before. Because EY1M0 can never be observed in the real world. How can you estimate that part, identify and estimate that part? It is very tough. So they actually develop this kind of approach. So first of all, they fit models for the observable outcome and mediator variables, and then they simulate model parameters from their sampling distribution, and they repeat the following three steps for each row of model parameters. So first of all, they simulate the potential values of the mediator. Then they simulate potential outcomes given the simulated values of the mediator. In this way, they're able to actually estimate EY1M0. And then they compute quantities of interest. So as I mentioned in the table, based on those 3 or 4 quantities, you are able to define natural direct and indirect effects and also average total effect. Then you are able to compute all of them once you have already estimated EY1M0. And the EY1M1 and EY0M0 are very easy to estimate. It's very similar to what we mentioned before when we estimate the total treatment effect. You just assume that the T is independent of potential outcome. You take the group mean difference, you are able to estimate total treatment effect. So for EY1M1, you just estimated with the group mean in the treatment group. EY0M0 can be directly estimated based on the data in the control group. But for EY1M0, they use this kind of approach to estimate it. Then they have summary statistics, including standard error and point estimates and confidence intervals. And also, more importantly, they have sensitivity analysis. Because as I mentioned in causal inference, people usually argued against whether you have, whether you have satisfied the identification assumptions. They really want you to control for as many confounders as possible. So you use sensitivity analysis to tell people that I have already controlled for enough confounders. Even if I ignore one confounder, my conclusion will not be reversed. Then that's good. I actually have a very good package, including everything that people may want to ask in the causal mediation analysis. So so this is, I will recommend this package. And another algorithm is non-parametric, is just based on Bootstrap, just combine Bootstrap with the algorithm 1. And I guess you may want to ask, where can I find that? More information about the package. I actually have these 2 links may bring you to the website. They actually wrote many papers on that. They have a website, and those papers are cited many times. So yeah, I believe you will find it very helpful. And finally, I will talk about the weighting method, which is also a method that really want to recommend, because the nice thing, I'll show you the method first, and you may see the nice thing about the method. So as I mentioned before, there are 4 cells. First, to simplify the problem, to simplify the discussion, I'll focus on 3 cells. For this cell, as I mentioned, it can be directly identified by the expected outcome in the treatment group. And for EY0M0, it can be easily identified by EYT equals 0. And the tough part is this part. How can we identify it? We can actually identify it in a very simple way. We try to use weighting to identify it. So we weight the data in the treatment group. Then we're able to identify it. Actually, we have a derivation in the paper, but I didn't show it here. If you're interested, you can read the papers that I will show you later. So W takes this form. So the basic idea, the key point is that the weight helps transform the distribution of the mediator under t equals 1 to resemble that under t equals 0. So that this t equals 1 group can be used to identify the unobserved Y1 M0. Yeah. So every time when I talk about this, people will feel confused, but I think after you look at the derivation, it'll be easier to understand. So these are the references I would like to recommend. So this method was initially developed by my advisor, Professor Guanglei Hong at the University of Chicago in 2010. And then later on, people have been refining this method. And the other researchers like Huber, Lange, Chedin have also developed methods, but those methods are all about weighting. The major strength of this approach is that it does not rely on correct specification of the outcome model. As you may already found, there's no outcome model involved here. We only need to model mediator on the treatment to estimate these probabilities. And then we are able to estimate each cell. By taking the difference between the 2 cells, we're able to estimate the effects that we really want to estimate. So you don't need to worry about the misspecification of the outcome model. If you want to implement this method, you can go to this website and download the software called RMPW. Then it also includes balance checking or some other things involved in causal inference. Finally, here are the references that I mentioned previously. There are 3 pages of references, including, I think, very important papers in both causal inference literature and in causal mediation analysis literature. So yeah, this is just a very rough, general introduction of causal inference and causal mediation analysis. If you're interested, you should definitely read those books. And so many people are developing methods in these fields, and there are still a lot of problems to be solved. But it's a really very interesting field. Yeah, I really want to see more of you come into this world. Thank you very much for listening.
Thank you. I think it's a very great introduction. As she said, if you are interested in this topic, please just check those references she mentioned. It would be great to learn of. Even just know the concept of the causal inference is good, because you realize that real world may not be as simple as you think when you generalize a causal inference. Let me final check if we have more questions. And if you have questions, please just leave a message under the event page, or we will stop here today. I don't think we have any further question.
And if you have any questions and you would like to, you could email me, and this is my email address.
Thank you, Xu. Thank you, everybody, for listening.
Thank you very much, Hui.
Bye.
Bye.